Hi there, it's Matt Heffernan. Welcome back to my channel. If you saw my last video, it was about the XCI game engine that I created for the Commander X16 retrocomputer. If you want to get a good overview of what this engine's all about, I'd recommend going back and watching that, or some of the demos that I have of the engine already, including a walkthrough of the example game that I created for it. And in that last video, I showed you a very rough overview of how that game, the example game, was actually created. And what I'm going to show you now is how to, rather than working from the example game, how to create a game from scratch using the bare bones template that also comes with the engine. But before we get into any of this, I want to cover the first topic that I want to explore in depth, and that is graphics. What I've found from interacting with folks on Facebook and elsewhere, that graphics seems to be something that generally throws a lot of people. If they're just used to doing programming in BASIC, a lot of text-based stuff, dealing with the specific graphics hardware is kind of difficult. So I've created a means of abstracting that away from you for the most part, and making it much easier to bring graphics into a game and just make the whole game design process a lot easier, especially when it comes to these point-and-click style adventure games. So, the basics of the graphics for this engine are, you have three different kinds of graphics, as we can see in this diagram here. At the bottom layer is Bitmap, and the bitmap is the background image. And whether that's in the title screen or in the game levels, that's sitting behind everything else. Above that is a tile layer, sort of a checkerboard of little graphical squares that can be placed on top there. And those tiles include things like different controls within the game and all the text that you can see in there. All of those are actually implemented with tiles sitting on top of that bitmap. And then on top of everything are the sprites. And sprites are also little graphical squares, but rather than being fixed to this checkerboard tile map, they can be placed anywhere on the screen and are very helpful for doing more detailed animations rather than just turning tiles on and off. So let's get into that first layer, the bitmap. In order to do that, we need to understand first about the color palette. For the X16, you get a 256 color palette, and that's what we can see at one time on the display. But for the purposes of this engine, each of these components I have limited to 16 colors. And so what that means is that the actual palette for these different elements, whether they're bitmaps or sprites or tiles, is they can use only a single 16 color palette offset within that larger 256 color palette. Now, palette offset 0 is the default palette, those first 16 colors, and that's what gets used for a lot of stuff, and a lot of the things you're going to be seeing today are all using that default palette. Then we have palette offsets that are used for each level within the currently loaded zone, so that each bitmap can have its own special palette. And then there are the next 4 palettes are basically for text rendering. And then the last palette is for all black. And that's mainly used for the bitmap layer, so that we can just shut the bitmap off and be able to change in a different bitmap and then load the palette in after that, so that you never see a bitmap rendered with the wrong palette. And that's basically it. We'll talk some more about how we're using these. And of course, these slides are available if you clone the repository for XCI. All of this is available for you to peruse at your own pace. So now the bitmap. So rather than using the full 640 by 480 resolution of the X16, XCI only uses 320 by 240. It's effectively scaling up the display by 2 in each dimension. And so now for the bitmap, you can use all of that for the title screen, the full 320 by 240. But once you get into the actual game levels, you're going to have the menu bar on top and the text field at the bottom, which you can see in those previous videos. And that ends up limiting our space to just 200 pixels high. So those level bitmaps, 320 by 200. But in all cases, we're talking about 16 color bitmap, 4 bits to define each pixel. And each bitmap has its own dedicated palette offset where you have one color, it must be black, that index 0 has to be black, otherwise it's going to be black no matter what you do. So you got to make sure you're setting up the palette for that first color to be black, and then the other 15 colors can be literally whatever you want, any 12-bit color value you desire. And then the main thing to remember about bitmaps is bitmaps are not animated within XCI. If you want to do animations, you have to do it with turning on and off tiles or sprites or moving sprites and so forth. There's no direct poking into the bitmap in memory and changing things around. So how do we actually create this bitmap? Well, I use GIMP. GIMP is nice and free. And here I have, as you can see, a 320 by 240 bitmap. I'm using RGB color right now. And what I'm going to do is just create a little scene. I'm going to first just make everything blue because I'm going to have a blue sky. So I select the whole thing and let's see. Well, the sky's blue and it's, say, we're going to make it about this color. See, I can just pick whatever color I want. It doesn't have to be from that default palette. All right, now I'm going to cover up that for the most part with green. Now I'll keep the horizon a little lower than that. So like right here. And we're going to make that green. So our grass is going to be about this color. And I'll go ahead and fill that in. And then we want, say, a friendly sun in the sky. Nice big sun. And that sun's going to be a golden yellow. There we go. And let's fill that in. And then, just to be fun, let me go back to black here. Let me get rid of that selection. And I'm going to create a little happy face. There we go. Here's little eyes. Here's our little emoji sun. Hey, how you doing? All right. I'll fix that eye so it doesn't look quite so bad. But there we go. There's our background scene. Now, this is still not in the format that we need for an XCI game. We need to convert this to a 4-bit per pixel raw data image. Luckily, you can get most of the way there with GIMP. So first what we want to do is index our color palette. Get it down to 16 colors. So we'll change our mode to indexed. I've already got it set to 16, and I'll go ahead and convert it. And it looks pretty much the same because I only used 4 colors to create the thing. I go over here and look at the palette, and there's that black in that first position where it needs to be. And then the rest of the colors, we got some little shades of green and blue to sort of help with some of the anti-aliasing, a few shades of gray. And there we go. There's our palette. So I can save that as is, but now it's in that XCF file format. And that's not what we want. If we go here to our main configuration file, we can see that, all right, we've got some of these top level files that we need to define. We need to find a palette.hex file. We're just going to use the default one with that. That uses the default X16 color palette for that first palette offset. We're good there. And we're going to look at the tiles and sprites later. We're not concerned with the menu at this point, but the title.xci, that defines what's in our title screen. And we're going to go change that right now. So by default, you basically don't have a title screen within the template. It sets the duration to 0. Everything else is a comment. So what we're going to do is make this last a healthy 10 seconds. Now the duration has to be in a number of jiffies. In a jiffy, there are 60 jiffies per second. So 600 jiffies is 10 seconds. And we do want a bitmap. So we're going to uncomment the bitmap. And you know what? Bitmap.data, perfectly good file name for our bitmap, even though we called it something else when it was a GIMP proprietary format. So what I'm going to do is export, whoops, wrong one. I'm going to export as And oh look, it looks like I've done this before. It's almost as if this was the third take of me doing this video. And there's a bitmap.data in that template directory, and I'm going to go ahead and export that. And now if I go over here into the directory where I put it, we're going to see it put in bitmap.data and bitmap.data.pal. And that's the other nice thing about what GIMP does, is when it does a raw data image, it of course exports the palette for you and puts it in a file where the file name for the palette, it starts with the file name of that main bitmap image and then just adds .pal to it. But meanwhile, all of this is in a 8-bit per pixel format and 24-bit color. And so the software development kit for XCI will automatically be able to change that for you into the format that we need. So let's move on now to the next layer, the tiles. What tiles are we going to place on top of our screen? Well, what we're going to do is basically the world's worst Pokemon game. In fact, it's just going to be a title screen for one. So what can we do to do this? Well, available for our tile layer is a 40 by 30 tile map. Like I said, it's a checkerboard. So you can place those tiles in those positions. These tiles are each 8 by 8 pixels, and you can define up to 720 unique tiles. And again, like the bitmaps, they are strictly 16 colors. So that's 4 bits per pixel. And then for tiles, we have special palettes, special palette offsets for use with tiles. In our case, what we're going to do is create things for that default palette offset, but as we saw before, there are palette offsets that define how tiles look if they're in a menu or in a text field and so on. So how do we actually create that? Well, packed along with the template, as you'd seen in the previous video, I have a spreadsheet to define that, but this spreadsheet is all stripped out. It doesn't have any tiles defined except for the first two. The first one is the one that you absolutely positively need to have, which is tile 0 being all black. Fine. Very easy. Keep that in there. You got another 719 to go. And then I very strongly recommend having an all white tile, or at least some sort of solid color tile that you can use for the different controls within the game. In the template, I'm using this tile for spaces within the menu, and so we're keeping that in there. So we're going to define our first tile and only tile here. So to do that, I am going to make a little Pokeball. So I'm going to make it white on top. So let's make it white here, and here, and here. And I'll make it red on the bottom. So down here, I'll go to red. You notice here I'm just changing the fill color on here, and the fill color is based on the palette. And you can see right here, here's that default palette, so that we know that the background of black is index 0, the red is index 2, the white is index 1. So now we know what it's going to look like, and we got it nice and blown up within the spreadsheet. We'll save that spreadsheet right now. But we need to be able to actually get this in a encoding that the SDK is actually going to be able to translate it. Here, let me get rid of this, and I'll bring up our tiles.hex. We don't need that either. And now we look here in tiles.hex, and we can see pretty much what we're expecting to see. We have a whole bunch of zeros for each of the pixels of that first tile. And since this is 4 bits per pixel, we just have one hex character, one hex digit per pixel. If you're not familiar with hexadecimal, it's real simple. It's instead of just having 0 through 9 for your numerals, you have 0 through 9 and then A through F. And so A is equivalent to 10 in decimal and F equivalent to 15. And if you saw a 1 0 in hexadecimal, that would be the equivalent to 16 in decimal. Very basic like that. So now all we got to do is for each pixel within one of these tiles, I just got to replace over here one of these zeros with a digit from 1 to F. So for white, I'm going to start putting in some 1s. So I'm going to need some ones here and some ones here and some ones here. And then red is 2. So I'm going to put some 2s in a little mirror image right below. And finally on the bottom. And there we go. Now we've created a tile. So let's keep moving on here. The next layer and the last one, the one that sits all the way on top, are the sprites. Now for the X16, you get 128 different sprites that you can have on screen at any time. And but if you're using the mouse, that mouse cursor has to be sprite index 0. So for the game, you can still control the look of the mouse cursor. You can replace that with whatever sprite frame you want. But in terms of sprites that you can actually control programmatically, it's those other 127. And now, unlike tiles, which were 8 by 8 pixels, the sprites are big, relatively big, 16 by 16 pixels. But that's still kind of small. It doesn't take up a lot of real estate on the screen. So for some figures that are larger, you may want to make multiple sprites to represent them. Like if you saw in the example game, I have the car that rolls around. That uses 2 sprites that are adjacent to each other and moving around in a synchronized fashion. So you may have to do something like that for yours. But for what we're going to do, we're just going to create a single Pokemon that will fit within those 16 by 16 pixels. And again, everything is 16 colors, 4 bits per pixel. And you can define up to 512 unique frames. So any of those sprites, including the mouse cursor, can be any one of those 512 frames at any time. And the only stipulation is that for mouse cursor frames, you're forced to use the default palette for those. But for the rest of the sprite frames, you can use whatever palette offset you want. So if you want to make it look like your background is changing a little bit with sprites, you can use the same palette for that bitmap for the sprites that are causing that animation sitting on top. So. But let's go back to our spreadsheet here. We're going to move over to the Sprites tab, and then you see a similar thing where we have that one default sprite frame, which is that default mouse cursor. And we're not going to change that here, but you're totally free to change that mouse cursor to look however you want. Just to realize, like the tiles, that the black parts are going to be transparent. So if you put like this part, I made gray rather than black so that it would actually show up. If you made it black, it would just be these little white bits that are hovering around. So let's create a silly little Pokemon. And of course, Pikachu is the best Pokemon, so we're going to create a very crazy, not terribly detailed version of our friend Pikachu. So he's got some legs, he's got a pointy head, he's got some ears that stick out like this, and he's got some arms that stick out like that. We'll give him little hands to come down, and then coming out of here, he's got a tail, and that sticks up. And we'll give him some red eyes / cheeks. Doesn't matter. Just a little color to throw in there. And there we go. Don't be too, intimidated by my awesome graphical skills. As you can see, you can just bring to it whatever you have. Get your friend who's better with graphics to make things for you, and everything will be cool. Don't worry about it. So now let's go and do the same thing like we did with the tile, is we've got to then implement this guy in there. It becomes a little more difficult because we're dealing with a larger dimension, but here we can see we'll start with the ears. So those are 3 pixels down and 4 pixels in. And then it's 5 pixels from the end, and those are all going to be yellow, and yellow is 7. Don't just take my word for it. There it is. 7 is yellow. And then in the middle, we got his little head poking up there. Under there, we have the eyes, which are red, so 2 for the eye, 7 for the bit between the eye, 2 for the other side of the eye. And then down here, all 7s. Again, all 7s. Then down here, more 7s for the arms. Down here, 7, 2 zeros for to have under the arm, 3 more 7s, 2 more zeros, another 7. And then we're finishing the rest of the body here. As you can see, it's a little painstaking to do this, but it does give you a very precise amount of control in terms of where your pixels are going to be placed. And when you get into actually animating, like if I were to make different frames with his legs walking, his arms waving, his tail twitching, whatever I want that to look like, I can have a very precise control over what that's going to be. All right, now just make his tail start sticking up this much. And what did I have it go? I had to go over his shoulder. All right, so one more 7 up here, and that's it. We're done. Now, as you can see, within these files, you can't really see what it's going to look like, which is why the spreadsheet is a nice sort of reference that you can have. It's a nice way to organize your sprite and tile designs, but you don't have to use that. You could use whatever software you want for the initial design, but then when you come to actually implementing that, you're going to have to spit them out into these hex files. You may be able to have a way of doing that programmatically. It's pretty easy. So anyway, there it is. So now we've created all of the graphics that we're going to put in the title screen. So we've already uncommented the bitmap. Now we got to start the animation. So we're going to want to place that tile pretty much right in the middle of the screen. Now, if we go back here to our syntax documentation, we can find here the tiles instruction is how we do that. And we say, all right, we do tiles, we do a palette offset, then an X and a Y value, and then a set of tiles that are going to be rendered in a row. We're just going to have the one tile, that tile index 2. So we're just going to put that right in here. We're going to say tiles, using tile offset, palette offset 0 for that default palette. And we're going to put it in the middle of the screen. Now we got, remember, 40 by 30 tile map. So we're going to do about 20, 15. So 20x, 15y. That'll get us pretty close to the center of the screen. And then that one tile index, number 2. And then the next one is the sprites. We want to define that little Pokemon sprite to be able to also be pretty much in the middle of the screen. So first we have to define what frames we're using for the sprite. In this case, we're just using a single frame. Very simply, so sprite frames. Looking again at the arguments there, we use the sprite index, which is going to be 1. The offset, again, 0, because we're using the default palette offset, and then our set of frames. And again, just 1 frames, and it's kept real simple here because the index and the frame are going to be the same, which is 1. So 1 and 0 for the offset, and then 1 for the frame. And there we go. Now we defined what the sprite looks like. Now we got to place the sprite. And we do that with the sprite instruction. And that's also pretty simple. You just say sprite and then the index. Again, that's 1 for us. And then an X and Y coordinate. Now, unlike the tiles, where you have a tile map grid to actually have coordinates for, these are down to the actual pixel level. So we have that 320 by 240 to work with here for the tile screen. So I'm going to again give it that sort of halfway point and say I'm going to have sprite 1 sitting at 160, and 120, so halfway in for each dimension. And there we go. There's our whole animation for the title screen, all made. So to make this work, what we got to do is call the SDK. There's the XCI.exe executable, and we pass that main.xci file into that, and that will build our game. And now if we do an ls, we'll see all these .bin files are in there. We have main.bin, and we've got this ttl.bm.bin. That's that title screen bitmap we created, and that's now in a format that we can actually load up in there, and we'll see it's that, as we expect, that 38K size bitmap. And we've got our default palette as palette.bin. We've got all the binaries all set to go and load. So now let's actually fire up the emulator, and we're going to pass in that XCI engine program, and that program is automatically going to look for main.bin once it gets going and load up our title screen. And let's take a look. And there it is. Oh, what happened? We don't have our the right things happening there. What happened to our fun little sprites? We had that tile 2 all set, and title XCI. What's happening there? Tiles at 2015 and 2. What happened to our tiles? That's a bit unexpected. If we go back there and look again at tiles, it's offset 0. Let me get rid of this right here. We don't need that. Tiles, offset 0, X and Y, and then tiles. And that's 2. And then, ooh, you know what would really help? Is if I spelled sprite frames correctly. That would really help, wouldn't it? So I think what I was doing was covering up that Pokeball with some garbage data. Let's try that again. So you notice the SDK sort of silently fails if it doesn't recognize a key. There we go. Now you see, this is all in real time. I can't expect the third take to really be good. But there's our Pokeball, and there's our little Pokemon right next to him, and now it's gone. That 10 seconds is up. But let's say we want to actually move that little Pokemon away from there. So we'll add in a sprite move command. And again, we see we have a sprite move, and then we that index 1, and then a delay between frames. Do 30 frames per second. That's going to be 2 jiffies between each frame. And say we're going to move 40 pixels, 1 pixel at a time, to the right. So we're going to have 40 steps, and the X step is going to be 1, and the Y step will be 0. So we'll go ahead and do that right in there. And you know what? If you saw me misspell sprite frames on that first one, you're going to get a comment like extra hard. I tell you that right now. So let's do let's write our delay. We'll say 30 frames, and then to the right. So X1, Y0. We go ahead and build that again and run it. And there's, hey, our little Pokemon friend pulled off to the side. And that's it. And I can click, and that will quickly end the title screen animation. And that's it. So that's how I look in the graphics. Now, if you go ahead and clone the XCI repository, you'll be able to see this slide deck, be able to read it in detail, including this last slide, where I get into some more detail about how 12-bit color works and how we ended up getting what we got. And that's it. If you like this video, please like it, actually, with a click of your mouse. And go ahead and subscribe to the channel, and you'll get notified if you click on the little bell of when my next video comes out in this series. And we're going to cover some more ground in how to create a game for XCI. So I hope you liked it, and I'll talk to you later. Bye-bye.